to x. And we normally use this 1 equal to sign, which is the assignment operator, which to assign a value to a variable. The moment it becomes 2, which is 2 equals or equal signs, we normally use it to do comparison to see if, let's say, a value on your left hand side is the same as a value on your right hand side. So you can have, let's say, if x is equal to, that's double equal to y. So you can do the x equals to y. That is, if you are comparing the data in the x and y, that's where we use the double equal sign. So it's used for doing comparison. And we all talk of the plus plus, minus minus, that is adding 1 to a variable or subtracting 1 from a variable before assigning to that particular variable. In maths, also, we all know the greater sign is the same thing when it comes to programming. We also know the less than sign, and it's still the same thing when it comes to programming. But programming, when you want to say less than or equal to, so let's say 4 less than or equal to 5 is true because 4 is less than 5. You can also say 5 less than or equal to 5 is true because the equal sign makes it equal to 5 and 5 is equal to 5. So 5 can be less than or equal to 5, and which makes it true. So that's how we write, or we write the operator when we want to do less than or equal to under in programming. Also, when we have when you want to also do less than or equal to, this how also we do it, and that they are all used for comparison. They're less than, greater than, they are all used for comparison. And we have the or sign. You can come across a condition where you say if a is equal to, if x is equal to 1 or x is equal to 5, it should do this for you. And if you want to use the or, this is how we do the or. That's that's a caret, right? The double caret, that's what we use, and it stands for or. But then when you want to do the and, that is if x is equal to 1 and y is equal to 10, then the program should execute something for you or do anything for you. So this is how we write the and sign. There's double ampersand sign, and that's what we do. And the last operator I'll talk here is the modulus. In mathematics, commerce, we all remember in JHS, we all did modulus. In SHS, we all did modulus. And modulus means the remainder whenever a number goes into another number, the remainder, that's the modulus. So let's say 10 modulus 3. So 3 can go into 10, how many times? 3 times, with a remainder of 1. So 10 modulus 3, the remainder will be 1. Let's say 10 modulus 2. 2 can go into 10 5 times with a remainder of 0. So it means 10 modulus 2 is 0. So that's the basic principle when it comes to mathematics and with modulus in mathematics. And it's the same thing in programming, nothing changes. So if you look at programming, you see we have a lot of mathematical science over here. And it's the same thing we are also going to use in programming to do a lot of calculations and also a lot of conditional checks. Okay, cool. So we will move on. If you have any question or you have any input, you can just bring it up so that we can also know what is best, and also we can also move forward as well. Okay, cool. But if you think I'm also going fast, you can just alert me. Another. Hello.
Yeah, hello, we can hear you.
Yeah, it seems someone is not on mute and we are having some feedback. Okay, cool. So Andy also took us through arrays. And he took us through one-dimensional array, and I think two-dimensional arrays, right? And
Yes, sir.
this is a simple table that I want us to look at. We all know tables. So this table has got John, Daniel, Andy, Joe, George. And this table, when we take it to be an array, it starts from index 0 or the pointer 0, and it moves on incrementally. So from 0, we move on to 1, 2, 3, and 4. And we learned that if I want a value, let's say Daniel, I will just use the index 1 to retrieve Daniel. Likewise, if I want the value Joe, I'll use index 3 to also retrieve Joe. So if you are converting this into a code, a Java code, it's similar like this one. As we have the string, you define the array and the variable name, and you just bring your quotes and you put everything here. So this a one-dimensional. This is an example of a one-dimensional array, as we all learned last Friday. And it's the same thing. So as this table has now been converted into a code over here, and it's still the same thing as you can see over here. So that's the equivalent in a code form that's in using Java. We also talked of two-dimensional array of numbers, and also of, let's say, we have numbers and alphabets. So this is a table with 2 rows and 4 columns. So if I want to retrieve Joseph, what will be the index?
Sorry, please. Is it 5 rows or 4? Hey, sorry, 5 columns or 4?
Sorry. Come again.
Yeah, you said 2 rows and 4 columns.
Sorry, it's 5 columns. Sorry, because it starts from index 0. Yeah. Thank you for the correction. So if I want to retrieve a value, let's say Joseph, from this particular two-dimensional array, what will be the index for retrieving this name Joseph from this table? Always remember rows first before columns. What will be the index of Joseph? We all did this in mathematics, core maths.
01. Index 01.
Index 01. Thank you. That's correct. Likewise, if we want to retrieve the value Smith, what will be the index?
Index 14.
14.
Index 14. That's great. It means we are keeping up with the code, and I like that. So I'll quickly switch to one of the codes, and we will just go through as we go through the sessions. Can you see my screen? Let me comment it. Okay. So let's look at this one-dimensional array. This is an example of one-dimensional array, as we all talked last Friday. So if I want to retrieve index 3, what value do you think is going to be outputted over here? Hello.
If you say index
Joe.
3, are you referring to 0, 3 or 1, 3?
So can you see my screen?
I think the result should be Joe.
Yes, so that is correct. If I want to retrieve index 3, the answer is going to be Joe. So looking at this one, if I want to retrieve, let's say, index 1, what's going to be the answer?
Daniel.
Daniel, that's great. So we can go on and go on and go on. So now I know that we understand arrays, and we know that when it comes to retrieving data from arrays, it means we are okay with it. So we move on to just a small one. That's the two-dimensional array as we just talked of. And as you can see from here, we have the list of names. I've added the columns. There is the column 0, column 1, 2, 3, and 4. And these are the rows, row 1, row 2, as we saw in the table. So it's still the same thing over here when we are converted to the code. And if I want to get index 1 for the row and index 3 for the column, which data is going to be outputted?
Felicia.
Felicia. Okay, let's run the code and see. Great. That means we have Felicia. So the last one, let's try last one. What about if I add, let's say, 7, index 7, what will happen? What data are we going to have?
Undefined.
Why undefined?
Out of bounds.
Okay.
The result is, the value is not there.
The value is not there because this index, which is 7, we cannot find because this index starts from 0 and ends at 4. So if you define an index of 7, the program will crash because we don't have any index that we can have that particular data. So this one will not run. And therefore, as you can see from the screen, there will be an error, that's out of bounds exception. That is, you cannot retrieve that particular index from that particular array that we are defining. So we'll go back to our slide. Okay, great. So now we understand one-dimensional array and two-dimensional array. So this is one assignment that I want us to take, and I will send it to you in the group, and we all can have a taste of it and give feedback. We can as well also answer it over here. So look at this one. We are converting this table into a two-dimensional array in Java code, and just give it output for the following. Assuming your variable name is called
I can't
name.
see us. Excuse me, sir. Can't see your screen.
Okay. Who can see my screen? Can anyone see my screen?
I think you have to stop and share again.
Yeah, I can see your screen.
Yes, I can see your screen.
Okay.
Okay.
Let me stop and share again. Can you see my screen?
Yes.
Yes.
Okay, great. So there is an assignment I want us all to take and work on it. So we are going to convert this table into a sample two-dimensional array, and we are going to retrieve the values with using the index 1 and 4. Sorry. And index 3 and 4, index 0, 2, index 3, 0, and also index 2, 3. And I would like you to present this assignment also on the page. Just a small file, and you can just send it. So probably you can do it in using your email or something, and we will share that on the page. Okay, so let's move on. So we start with today's lessons, which is loops. When we talk of loops, loop is a sequence of instructions that allow us to continue to repeat until a certain condition is reached. So let's say you have a list of names and you want to be retrieving all the names and adding values to it or checking where these names belongs to in memory. You can't be using the index one by one, say index one, then you retrieve and do whatever you want to do. We have special sequence of instructions that you can follow, and the computer will do all these things for you. So that's how come we have the loops. So if you go back to this two-dimensional array, one-dimensional array, you can't be doing names list, then you say 00, then you will do it. You write another code, names list 01, and you write another code on it and execute on it. It will not be efficient because you're going to waste a lot of time. Assuming the data in here, there are hundreds or thousands of them. Can you be writing index to retrieve all this data and manipulate on it? That's a big no, because that will be a boilerplate code. So we need to make sure that we write a code that we just leave it to the computer and the computer will just run everything for us. So that's how come we have the loops. So they allow us to repeat a single or several lines of code over and over again. So you just write a small code, and this small code will just run all the thousands of data for you, and it will do all the manipulations for you. And this allows us to write once and then execute many times, anytime we want. So there are a lot of loops, because over here, when we come to Java, I have for loops. For loop is also available in other languages. While loop is also available. We have the do while loop, is also available in other languages. We have different types of loops, but these are the three main types we are going to learn, and these are the common ones that we want to associate ourselves with. For loops, as we learned some time back, that was a week ago, Amos took us through the for loops, and I remember we were all okay. We started with the for loops, and the for loop, they are used whenever you know how many times you want to execute a statement or a function. So let's say you know that this data is up to 100, or you know that this data is up to 1,000. That's why you know the number of data in there, so you can use for loop, and you can work with this for loop. But then if you don't know the number of data in there, for loop will not be suitable for you. You can probably go for a different one, like let's say while or do while. But if you know the number of data in there, for loop can also work for you. But in other higher languages, you can also still use for each. That's the another higher thing that you can also use, even if you don't know the number of data in there. So for, so if we want to do the for loop, we start with the keyword, the for. And normally, since it's a list of data or a collection of data, you need to start with where you want to start your looking for or retrieve the data from. So let me go back to this one-dimensional array. Assuming I want to retrieve data, or I want to manipulate on data from index 1 to index 4, I need to initialize my for and tell the for that start from index 1 and end at index 4. So in this case, I'm not going to operate on index 0, which has the data John. So it's not always your initialization should start from 0. You can start from any index and end at any index, depending on how you want to write your logic or how the code or the distance demands, the data demands. So you can start from, let's say, index 2 and end at index 4 with this one-dimensional array. So if I want to start from, let's say, 0 and end at 4, I will say that, okay, fine. Since the index, normally index are zeros, ones, and twos, and they are all integers. You can't have double in there, you can't have anything there. We normally say int. In other languages, you say integer, but int is the same as integer in other languages also. So you say int, and you define your variable. So your variable can be any name. It can be int counter, int pointer, int x, int I, or anything. So the variable that you use will be the same thing that you use throughout in your code. So if I say int I equals 0, that means I'm saying that the for should start from index 0 and now can now operate on all the other data till, and I also tell the for that it should end at, let's say 4 or end at 3. So with a for, you have the option to start anywhere and also end anywhere in your code. It's not always that you should start from 0 and end at the last data. You can say that, okay, if I want to work on, let's say if the data is 100, you can say I want to start from index 20 and end at index 80. So I'll tell my data that for, I'll use the keyword for, as we have here. So initialization is important. And I'll say the initialization, say int I equals, if as you can see over here, int I equals 0. And I'll say, okay, fine. Let's say we have 100 of data. I'll say int I equals 0. And I'll tell the computer that when you get to a number that is less than or is the same as 10, that is less than or equal to 10, I will say that you stop over there. So these are the two conditions. The first one and the second one are the boundaries that you set for the computer that start from 0 and end at a certain point. Then the third variable, the third statement over here, which is the I++, you are going to tell the computer that, okay, fine. When you are done retrieving the first data, I want you to move on to the next data. And over here, I want to let you know that it's not always you also tell the computer that when you are done retrieving John, you should move on to Daniel. No, I can tell that if fine, when you're done with John, move on to Andy. So it means instead of incrementing my I or X by 1, I will say increment it by 2. So if I'm at 0 and I increment it by 2, it will skip Daniel and move on to Andy. So that is what you also tell the computer to also do. So it's not always it's I++. You can say I plus 2, which means anytime it does iteration, it should skip on to the next index, which is the double of that is plus 2 of it. So that's how we also write the for loop. And in between the curly braces, you can have your code over there or the logics in there. If you have a question, you can bring it up, or you have anything also, you can let me know. Am I clear on
Hello.
that? Yeah, hi.
Yeah, please. Is it always I? Is it because it is an int that is why you are using I, or it can be any variable? Sorry, any letter or variable.
Yes, sure. It can be any variable. It can be any letter. So let's say I have let's say positions. It can be a lot of a list of positions. So I can say int position equals 0, and I'll say position less than or equal to 10, and I'll do position plus plus or position plus 2. So this is the same thing that we learned during the variable naming. So this a variable that I'm naming. So I can name my variable I can say variable Ama, variable Koju. But then when you are giving names to variables, they should be meaningful, as we learned the other time. So this is also another variable naming.
Okay.
Am I
Please, yes, and then one more thing. I can see that this is for Java. So is it the same for other languages?
Okay, it's not the same for other languages. Other languages will, let's say in Ruby, they will all they have something called in. So they will specify the value and they will say, and they will do but then it's similar and the concept is still the same thing. So if you learn it here and you want to transfer it to other languages, it's very simple.
All right, thank you so much.
You're welcome. So we will quickly share the code parts And we also look at how it's been done over there. Can you see my screen?
Yes, please.
Am I too fast or it's okay? So let's look at this data. We have this list of data over here. That is what we had from the table. We have John, Daniel, Andy, Joe, George. We want to output all these to the computer, to the user. We can say that in Java, you can use the system.out.print or the print line. The difference between the print and the print line is print will print, but the print line will print on the next line. That is, it will give you like a paragraph, something like if I'm explaining. So to just print on the next line for you. You can say names list and you retrieve index 0. Then you want to print all these names on the computer and you'll be writing this. And after that, you come and write print index 1, 2 for me. You come and say print index 2 for me. And it's assuming there are thousands of data. You can't be doing all these up to the 1,000th data or 1,000th item. You just have to use the for loop. That's okay, fine. I want you to start from index 0. Just run through and print all the data for me. So I'll say, so the one who asked whether we can use I or anything. So I'm saying index. I'm using index as my variable name. So I define int index equals 0. It's the same as in commas where you can say let x equal to 4. And automatically we know that x is 4. So I will say with me out, I will say that, okay, let's index equals 0. Automatically index is 0. But over here in Java, you need to let the compiler know that, okay, this variable that you've named is integer or is a string or is a character or is any other data type. So that's why we are using int index equals 0. And when you are done with a statement, you terminate. This is how we terminate. Terminate, you use the semicolon as we learned. Bismarck taught us. So you say int index starting from, so I want to print all these names over here. So I'll start from index 0 and I'll tell the computer that when it gets to this names list. So I learned, Andy also taught us how to get the number of data in an array. You can use dot size or dot length, depending on the language. So in Java, we use dot length. In that, we use dot size. I think in Ruby also, I don't know about Ruby, I don't know whether it's dot size or dot length. Yeah. So we have different languages. You have like hundreds of languages. They all have a way of also writing they have their own syntax. So in Java, if you want to know the number of items in here, so if I count 1, 2, 3, 4, 5, the moment I will say names list dot length, it will give me 5. So automatically I know the size or the length of the array. So I'll tell the compiler that, okay, start from index 0, that is from John. And when you are less than whilst you are less than, this is the condition. Whilst you are less than the length, which is the 5. So now length here is equal to 5. So we know the length now. So whilst you are less than 5, increment by 1 and be retrieving the data and print them for me. So if, let's say, index is 0, I will just get the value over here. So index is 0 to give me John and it will print. Since it's for loop, it will now go back again with this incrementer. He said it should increment by 1 because I did plus plus. So now x will no more be 0. It will now turn into 1. And whenever I put 1 here, it means we are going to get Daniel. and now Daniel will be printed. And since it's a for loop again, this incrementer is saying plus plus. So now the value is not more going to be 1 again. So now the value is going to be 2 here. And when we put 2 here, as we all learned from the first one-dimensional array, I'm going to get Andy, and now it will be printed to the screen. It will do and do and do till this condition is met. So the moment it gets to, let's say, index of, let's say, 4. Since 4 is still less than 5, because that's the length. So if now index here is 4, and it is less than the length over here, which is we know to be 5, still this condition will still run, and it will print index 4, which is 0, 1, 2, 3, 4. So if it prints now, since we know that the length is 5, and this index increments from when we are here, we have 4 increments to 5. It will now compare, is 5 less than 5, which is false. So therefore, this for loop is now done. It's done with its job, and it's no more going to be executed. And we are done with the for loop. So let's run this code, assuming index is starting from 0, and we are retrieving this whole data over here. We just run this code. So it's going to output John, Daniel, Andy, George. So let's assume we are going to do index. Let me do, let me start from even do this one first. Let me start from index 1. So this means I'm going to ignore index 0, and I'll tell the computer that I should start printing the data from Daniel, Andy, George, Joe, and George. So if I tell the computer this way, that's going to be the output. So let's run this. So you see, it's no more printing John, because we told the computer that the index should start from 1. So it's going to start from index 1, 2. So it's going to start from index 1, 2, 3, and 4. And that's how we render for loop. Any question? Are you okay? Okay, great.
Yes, please, but I have one question.
Okay, cool.
Yeah, so for this one, is one-dimensional array, right?
Yes.
All right, thank you.
I think Michael Edu also wanted to ask a question. Michael, you can go ahead.
Oh, no, I was saying I'm okay.
Okay, great. So we move on to using the while code or the while keyword to also do a loop. So now we all know how to use the for keyword to run through or iterate through a list of data or collection of data. We can as well also use the while code to also iterate through a list of code. And I'll share my screen once again to this code. Can you see my screen now?
Yep.
Okay, great. So with the while loop, though the for loop told us that you need to know the length or the size of the array before you can use the for loop, and that's what we just demonstrated. With the while loop, we don't even need the length of the whole array. And what we need is, for while loop, it first of all checks a condition. So if the condition is met, then the code will run. Otherwise, the code will not even run. So I'll say int x equals to 1. So it's the same as I said in commas, we say let x equals to 1. In this case, here we are using the assignment sign, which is 1 equal to sign, so that we can assign or give data to X. So now X is no more normal data, so X contains the data 1. So we are going to compare and see. We say why. So while Andy has not been here, let's continue to eat the food. It's like you speaking the normal English. While Andy has not been doing this, okay, let's continue to do this. So that's what you tell the computer. So we say why X is less than 10. And is it true that X is less than 10? Yes, because X is 1 and X is less than 10. So this code will be executed. And now you tell the computer that, okay, fine. After you are done, this X, please add 1 to this X and assign it back to X. So if X was 1, I'll add 1 to X and I'll assign it back to S. So now X becomes 2. And it will now go back to the while again as the for loop was doing. So it will still iterate. So you say it's 2, which is X, less than 10. Yes, it's true. And it will print this particular code for us. It will now add 1 to X again. So now X becomes 3. You go back to the while loop again. It runs. It's still less than 10, which is true. So it continues to run till it gets to when X is equal to 10. Is 10 less than, okay, let's say X is equal to 9. Assuming we are at the 9th iteration. And we say X is 9 less than 10, which is true, to run. It will increment it again and it goes back. So now X becomes 10. It's 10 less than 10, which is false. And now this while loop is like it will die. That's all. So it will just finish executing. And if there's any other code beneath here, it will continue. And that's it. Okay, I can see someone's hands raised. And if you have any question, you can, or any contribution, you can bring it up. So let's run this code.
Please first one.
Come again.
Yeah, Michael, you can talk. We are listening.
No,
Okay, we can proceed. So as you can see over here, we are printing render X, which is the value of X. When X is 1, it will print 1 for us. When X is incremented,
please continue.
It will print for us. So that's how come we have render 1, render 2, render 3, up to render 9. So when X becomes 10, X cannot be less than 10, cannot be less than 10 because 10 is equal to 10. And this particular code will not run again, and that will be the end of this while loop. Likewise, we can also have the do while loop. And the do while loop also renders the same thing as the while loop, just that with the while loop, a condition is being checked before the program is being run. But with the do while loop, when you look at this, it will first of all run the code in here first, and now come and check the condition which you've set here. So it means with a do while loop, the code can run at least once before it checks the condition, that if the condition is true, and can now execute the rest. So with a do while loop, it's like if you don't want your code to be executed at all, you can't use the do while, because the do while loop will execute your code first before it even comes and check your condition over here. So what it does is when X is equal to 1, okay, fine. You say print this first. It prints this. You now come and increment X plus 1. So X now becomes 2. It will now go and check why X less than 10. So it will now come and say if 2 is less than 10 before it go back again and go and run this particular code again. So that's the difference between the do while and the while loop. I know we've learned this in our previous 2 sessions. We are just repeating because there's the loops and we want to delve deep into it. If you have any question, you can bring it up. So this one also, when we run, we're also going to get render from 1 up to 9, and it's still the same output as with a while. So if you have any question, you can bring it up because we are also moving on to another session.
Yes, I have a question. If I don't want to use the for loop, and I still want to use the while or do while loop for my array, can I do that? But it seems when you got to that section, you didn't use the array to display the names again.
Okay, so let's look at a small example. Let's copy this array here. So assuming we have this array, and we say we want to print the names in here to the computer or to the user. And I will say, why? So who can, okay, fine. Who can help me here to write this? What will be the logics over here? If I want to output all these names to the user, starting from, let's say, index 0. Hello. Who can help me here?
Yeah, hello.
Yeah.
Yes, I think should be while x is less than or equal to 5.
Less than or equal to 5. That is, you know that. So let's run this code and see whether it's going to run. Okay, cool. Let me clear the data here. And okay, let's output the names rather. Let's see. And let's input in X. Okay, cool. And let's see if this code is going to run. I'm going to get index out of bounds. Yes. So you know the reason why we are going to get index out of bounds?
No.
You know, the list here where we are saying
okay. It starts from 0. 0, 1, 2, 3, 4. Is that okay? So it should be less than 4.
Exactly, that is also correct. 4 is correct, or you can also say less than 5.
Okay.
That one is also correct.
Okay.
So let me explain this better. Probably somewhat. So when you say less than or equal to, it means, let's say less than or equal to 5. It means 0 is part, 1 is part, 2 is part, 3 is part, 4 is part. Since you brought the equal to, the computer will still go to 5 because 5 is also equal to 5. And when you want to find retrieve index 5 from this particular array, it's not going to work because you don't have any index 5 here. It ends as index 4 because we start from index 0, 1, 2, 3, and 4. If you want to retrieve index 5, it's going to crash. So that's why we are having the index out of bounds. So if you do this, it's not going to work. So if I do 4, it means it's going to be 0 to 4 inclusive. That is 0, 1, 2, 3. Since the equal to is here, we will have 4 in there. And it is still going to work for this array. Likewise, I can also say less than 5. Less than 5 means 5 is not part. That is any number below 5. That is from 0 to 4. And this one should work for us. Likewise, you can also do equal to with a 4. That one is also going to work. I don't know whether we understand this or it's confusing. Okay, cool. So in order not to worry ourselves a lot with these 4, 5 things, the best thing is to just use the length of the array. If you don't know whether the data in there is, let's say, is 20 or 15 or something, just use the length of the array. And the length of the array, I told you that the length of the array here is 5. So the length of the array is different from the index. You know the index ends as 4, but then the length of the array is the number of items in the array. So we have 1, 2, 5. That is John, Daniel, Andy, Joe, and George. They are 5. That's the length. It's different from the index, the last index. So normally the length of the array is normally the same as the index, the last index of the array is normally the same as the length of the array minus 1. So let's say, let me explain that. I will say this one index starts from 0 to 4. And the length of the array, the length of the array is equal to 5. It's still the same as that 5 minus 1, which will give us 4. So I can say the last index is always equal to the length of the array minus 1. And then I will tell the computer that I can say, okay, equal to this length minus 1, which is also going to work. I don't know if I'm clear here. Do you understand me? Because we know the length here to be 5. And when you subtract 1 from 5, you're going to get 4. And therefore, since 4 is the last index of this array, we can do the equal sign because we know that it will never go overboard. It will never get out of the boundary of that array. And this is going to work for us, the less than equal to. But then if I don't do the less than minus 1, it means this length is equal to 5. And therefore, I cannot use this equal sign as we demonstrated earlier. So this is the same thing as we did. Are you okay with this? Okay, cool. So if no response, we will move on and move on to the next one. So the next is going to let us learn. Okay, Andy, if you have something, you can chip in.
Thank you, sir. Like I said last week, for each element, it's like you place each element in a box and you label it. So as you can see, the name list displayed there. Yes, so as you can see it here, assume that each of the box has a label, and the label is 0, 1, 2, 3, 4. Now we know that the elements inside, when you count it, it's 1, 2, 3, 4, 5. At the normal circumstance, when you count, it's 5. But always bear in mind that when you are accessing the element in it, you access it not by the length, but you access it by the label on it. So if you pass a 0 into the array list the square bracket, you are going to get the content inside that box, which is John. The same way when you pass 4, you are going to get the value George. And the array, the inbuilt function called .length or .size, always return the number of elements, not the index, the last index number of the array. So for instance, if I do .length of this array, it's going to tell me that, okay, so the array contains 1, 2, 3, 4, 5 members. Meanwhile, when you want to access each of the members, there's no 5. So you always have to bear in mind that the number of people in the array is different from the labels against their names in the array. If you have that concept in your mind, you will not be confused. So that is why he subtracted 1, so that he can be able to get, and always it's like a formula. Always the number of elements, which is the total number of people in the array, it's always minus 1 of the last index number. So if you can see, it's 1, 2, 3, 4, 5. 5 people are in the array. But when you subtract 1 from the 5, you get 4, which is the last index number of the array. And that's what he was trying to explain, and I'm just highlighting on that. Thank you.
Okay, thank you. So we move on to the next one. If we are okay, we've done the for loop, while loop, and the do while. And now we move on to controlling our loops. So this where we need much attention here. So you have a loop, and you can't let your loop to run continuously and run and run and run and run. You can also at times also come into the or just come into some part of the code or the loop and do some kind of conditions over there, or even stop the loop. Assuming you have a list of data over here, or let me say, when you even come to this Skype, we have a list of people here who have joined, and I want to look for Michael. Starting from index 0, we will have a lot of people over there. And let's say Michael, we have like, let's say how many people are even joined here? Like I see 13. And I'll see, okay, fine, Michael is at position, let's say 0 or position 4. And I'm looking for Michael in this list. So it means I'm not even concerned about all the other people over here. So I'll tell the computer, okay, fine, look through this particular list. Using the for loop, I'll do the for loop and look through all the list. If you see Michael, please stop and just give me the output that, okay, you found Michael, and just give me Michael, let me go my way. So you don't let the computer to run the code and just be running. Meanwhile, you have what you want. So what again? Just stop and just go your way and stop executing the other, stop iterating the other data. You understand me? So these are some of the things that we normally also bring into the loops, even though the loop will be running. But then if you find what you want in the loop, you can stop executing the loop and it will stop. Likewise, we also have another scenario. If let's say these same participants over here in this Skype page, you are looking for let's say James, and you would like to say, okay, fine, I want to be adding James to a particular class. So if you look through and you find James, just add him to the class. But then if it is not James, please continue. Don't even do anything with the rest of the data. So I'll tell the computer that, okay, fine. If any code comes, just continue, don't execute. But if it is James, just do it for me. So this is also another way of also telling the computer that, okay, fine, I want you to do this for me. If it is not any of these, just continue. Don't even run the code. Just continue and continue. But if you come across James, just stop there and execute whatever you want to execute for me. So we have other keywords, as we have the for, the why, the do why. We also have other keywords that we can also use to control our loop. So we normally control our loops with some of these keywords. We have a lot of keywords, but we'll restrict ourselves to these particular two. We have the break. The break is where if you look through the data and you find Michael, just stop executing the rest. Let's say there are hundreds of data and Michael is at the 77th. If you found Michael at 77th, just stop executing the rest of the 27 data and just leave them. Just bring me Michael, and that's all. So we use break in our code to tell the computer that please break, don't even continue executing because I found what I want. So the usage of the keyword break allows us to exit a loop at any point. Any code after the break keyword will not even be executed and it will be ignored. The usage of the keyword continue, that's where we say, okay, fine. In Java, we use continue. In Ruby uses next. In other language, they use different syntax. But then if you learn one particular language, we are trying to use Java over here. But then you can also, when you learn other languages, you learn their syntax as well. You can easily send the same concept over there, and it's still the same thing. So the continue will tell the computer, okay, fine. If any code comes, just continue. Don't even execute. Continue. Just go to the next line. Just like I'm in a hurry. Just go to the next line. Continue until you find something that I want. So that's where we use the continue. So the usage of the continue or the next keyword is to allow us to skip the current iteration. So let's say I'm at iteration. I've started from index 0, and I tell the computer that continue. To not even execute the index 0, it will move on to index 1. And I'll tell the computer that, okay, continue, it will move on to index 2. So it will not even execute any code in that particular block or in the for loop. It will just tell the computer, okay, fine, continue, until probably I say that, okay, fine, if you reach, let's say, index 10 for that one, just stop there and execute the code for me. So these are the things that we are also going to look at. So we just use a simple code just to demonstrate that. Can you see my screen? So we're going to look at,
yes, please,
using the break keyword. So let's look at this list. We have John, Doe, Smith, Rita, Daniel, Philip, Joe, Felicia, William, Andy. So we have, like, these are the list of participants in the Skype group over here. And I want to, let's say, look for Smith. Or let's say I want to look for Rita. So what I'll do is I will write my for loop that, okay, fine, start from index 0 till you reach the end of the list. That is the names list of length. And now increment it by one by one. That is when you finish one, you go to the next line, you go to the next one, you go to the next one. That is the I++ as we've learned. And now, anytime I'll go through, if let's say index is 0, I'll retrieve the name into this particular variable, which is name. So if it's index 0, it means at that moment, I have the name here to be John. And I will say, okay, print the name John for me. It will continue and it will check, is the I equals to 4? You've seen this comparison operator over here, double equal to, we used to do comparison. Is it equal to 4? That's what we use for the comparison. So since I is equal to 0, I can never be equal to 4. That 0 cannot be equal to 4. So it will skip this particular code over here, and it will go and print this one, done printing. Now I will be incremented to 1. It will get the index 1, which is do for me, and it will print for me. It will compare to see is 1 equal to 4, which is no. So it will skip this particular block, and it will come and print this line. It increments. So it gets to when I equal to 4. Now when I equal to 4, when you put it into this array, when I equals to 4, that's 0, 1, 2, 3, 4. That is Daniel. The name here, this one will be executed. So to do printing Daniel. And it will come and compare, is I equal to 4, that is 4 equal to 4 is true. It will tell the computer that, okay, now I've seen that, okay, I'm index 4, then break. The moment it reaches here, this code will never be executed. It's no more needed. And the iteration will also stop. So it will not even execute and go and print Philip, Joe, Felicia, William, Andy. They are no more needed because I just want the index 4. So just print up to index 4. If you found index 4, just stop executing. And that's all. And that's the whole explanation of this particular code block. So we can execute it and see the outputs. Okay, cool. So let's look at these outputs. So to say printing John, that is index 0, and it will print this line, done printing. It moves on to the next one, printing do. It prints, then it prints, done printing. It goes to index 2, printing Smiths, and it can execute this one. It moves on, printing Rita, and then it comes to done printing. Now when it gets to Daniel, that's when index is equal to 4. It will print Daniel for us. It comes to this, is 4 equal to 4, yes, then the code should break. So even this done printing will not even be seen by the computer because there's a break over here that there's a condition that if I is incremented and it comes to 4, the code should break and the iteration should even stop. So the for loop will stop and the rest of the names will not be printed. So that's output for here. So the same way I can say, if I'm looking for, let's say, Smith, if I see Smith, please stop the code because that's a Smith that I want. So I'll say if name equal to Smith, please break and don't go anywhere. So the same thing, let's clear this. And it will run from John, Joe, Smith. The moment you see Smith, because you've told the computer that if you see Smith, please break, don't run an iteration again. It's Smith that I want. Just bring me Smith, and that's all. So that's the break statements. Is there any question? Hello.
Yes.
Are we okay with that? Or if there's any question, you can just bring it up.
Hello. Hello.
Yeah, I can hear you.
Yes. Yes. This is for just a single break, but in a situation where you want to print, let's say John, break, and then continue from Rita, then break, and then continue and print Joe, break again, and then print Andy. What
That's I like your question. That's a serious one. So over here, when you say break, the computer knows that this for loop is done a job and it will no more execute. But then if you, with your scenario, what do you want to achieve? Is it that you want to be getting the data John, Smith, Daniel, Joe, and probably move on to Andy? For that one, then you have to know the logics in there to use. But at the moment you use break, this for loop will never run again unless you call this function again that it should start executing again or should start this for loop again. Okay. But if you want to do that, you have to probably do a list of like you have to change your conditions, and also you have to implement a lot of logics in there. You can as well also use your indexes also to retrieve this kind of data as well. I don't know if I've answered your question or if there's any contribution.
That's fine.
Okay, great. So what I want you to understand is break will stop the for loop, or is to stop the loop running completely, and it will not run again unless you you start it again. Okay, so we can move on using the continue. So let's say I want to print all these names on the screen, but then when I see Smith, I don't want you to print Smith for me. Just continue and ignore Smith and print the others. So your question probably here, when you want to do that, you can't use the break, but you can rather use the continue. So I can say if name equals Smith, let me comment this one out, not needed. So if and bring this one here so that to realize that before this code. So let's do this. Sorry. So do you understand this part? I want to print these names. And I want to print this name, John Doe, Smith, Rita, Daniel, like this list. But then there's a particular person I don't want him. So when you reach his turn, continue executing, don't even print him. Because I'm not in good terms with that person. Don't print that person. I don't need him. So this is how to tell the computer to do that. So if name is equal to Smith, the moment you see that the name that you at that particular point of the actuation, if it's equal to Smith, please continue, don't print. So if in your case you want to print only John, you want to print only Rita, you want to print only Andy, then that's where you can say, if there are different ways of doing that. There are a lot of logics you can also use in here. I can do one way and I can also do the other way around. So I want to print only John. I want to print William. Let's say only John and William. I can say that, okay, you first of all, let's run this code. That is, I want you to ignore Smith and I want you to probably ignore Andy. I don't like him at all. So I will use the OR operator. You know the OR operator. We learned that not long ago. So I'll say if the name is equal to Smith, please continue. Or if the name is equal to Andy, please continue. Don't print these people. I don't like them at all. Print the others. And it's going to work for us. Let me clear this. So we have John, Doe, and it will skip Smith. It will go to Rita because I don't want Smith. Now to go to Daniel, to go to Philip, to go to Joe, to go to Felicia, to go to William. When it goes to Andy, I don't like Andy, so it will stop. So continue to is the same. It works like break in the sense that the moment you bring continue, any code below continue will never run. The same way when you go to break, the moment you bring break and there's a code here beneath the break, that particular code also will not run, it will cease. But just that for the break, it will stop the for loop at once because you said it should break, ceasefire. But for the continue, it will just skip everything beneath it. But then the for loop will still be running. That's the difference between the continue and the break. If you have any question, you can let me know. Our time is almost up. So please, if you have anything, just let me know. Okay, cool. Let's move on. Quickly, we will look at a story over here. Let's look at a story. So we are going to solve a particular story problem, and we probably end it here. We have other screens, but because of time, we didn't join early. Because of time, we might have to end because it's almost 9 o'clock. So we move on to the next. So these are some of the things you can have, uses of loops. So having an algorithm check through items in the list is incredibly useful. So that's what I cited. We have a list of participants. You want to retrieve Michael, and you don't have to be using index 0, index 1, index 2. So you just have to use the for loop and other things. So this is a sample story problem. And this, I want everybody to cooperate over here. We are going to write a code in Java to do the following. We are going to print all the names from the array below. So we have this array: John Doe, Smith, Rita, Daniel, Philip, Joe, Felicia, William, Andy. And if the array index, so during our looping, we will check the array index. Is the array index an even number? Then the computer should print even index. Otherwise, it should just print the data from the array from us. And the next thing is, if it sees Rita, it should ignore Rita and print the other names because we don't need Rita. We don't like Rita at all. We don't even see it on the screen. Then the next condition is if the array index is greater than 3. That is if we are doing the looping and we see that the index of the array is greater than 3 and the name is Joe at that particular instance, the computer should not print that data, which is Joe for us. It should print happy holiday. Can we do it? Or do we have the logics? Hello? Do you understand the story problem? Hello.
Hi.
So we are printing these names. Fine. If during the looping we find out that the index is an even number, it should print even index instead of printing the name for us. And also, if we find out that the name is equal to Rita, it should ignore it and move on to the next iteration. And also, if the index is greater than 3 and also the name is the same as Joe, it should not print that name for us. It should just print happy holiday. So let's quickly switch to our code and start working. So there's a story problem over here. Oh, I should give it to you as an assignment.
Yes, that would be
Can
great.
can we do something? Though I know we've not started with programming like actual practical thing, but then I don't know if we can still do something. Are you okay to use it as an assignment? So I'll just go through over here. I can't see people responding, so I think probably they will not like to. They don't have any clear view about it. They can't do that. So number one, they say we should print all the names of this array. So step one, if array to view, I'll say okay, fine. Step one, just do this for me. System.out.println line. And sorry. And it will print all the numbers for me. Then what next? Step two says that any even number index should print even index instead of the name. So when it is iterating through this particular list, is index is 0 an even number? No. Is 1 an even number? No. Is 2 an even number? Yes. So therefore, if it's an even number, instead of me to print, let's say index 2, which is Smith, instead of me to print Smith, I'll not print Smith. I will say print even index. Now it moves on to the next condition. It says the name Rita, and we've already done that, should not be printed on the screen. That is when we use the continue statement. So if it finds out that the name is Rita, then it should just move on. It should not even print because we don't want that person. The loop should continue running for us. Then the last one says if the array index is greater than 3 and the name is Joe, then the computer should print happy holiday. So it will compare and see that if is the index greater than 3 and this operator, this when we want to do and, that is to use this 2 ampersand, and the name is also equal to Joe. Instead of reprinting the name, we are going to print happy holiday, and that's all. Our code is done. Can we do that? Hello.
Hi.
Can you even hear me? Oh, you are silent. Oh, because of the code, that's why I ran away from me.
Yes.
Yeah, here.
Oh. So it's nothing big deal. So we have this.
Okay.
We have John, Joel, Smith, Rita, Daniel, Philip, Joe, Felicia, and others. And it's going to print all this for us, the name. But then when the index is 0, it will print even index. That is when it is 2, when it is 26, when it is 8, when it is 10, and blah, 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 others. Then likewise, when we see Rita, we ignore, sorry, was it, you say the name Rita should not be printed on the screen. Yes, that is should not be should be ignored. Okay, so let's look at our code. So if you see Rita, okay, cool. So let me look at this spelling. Exactly. So I think the reason why I did this was to give you this for you to go and fix the issue. Why? Because let me do this. Okay. Can you do it? Hello?
So you
Please come
will you
again.
we don't understand.
I will give you this sample code. Just look through it and just come up with yours. And if there's any issue, just fix it. Is it okay with that?
Yeah. Okay. Line 138. The else if.
Yes. Okay, cool.
138. Yes. I was thinking about the even number. So I was thinking if the index is multiplied by 2, even though this one will work, I'm asking if the index is multiplied by 2. So, for instance, if it's 0 and it's being multiplied by 2, then the answer will be 0, which means it's not an even number. If it is 2, it should be 4, which is an even number. Okay, since 1 is not, okay, I think I'm okay now.
Yes. Hello.
Yeah,
Yes.
hi.
Yes, I was about to ask the similar question. The even index. Can you also ignore continue from, let's say, index 2 and then I plus 2, so that when you start from 2, you can get 2 plus 2, you get 4, and you add 2, you get 6, you add 2, you get 8, you add 2, you get 10.
That's also another logic. So that's why I wanted you to go through and bring up your own solution.
Yeah, I think that one will work, but we are looking at time here. I think in programming the execution time is also important.
Exactly.
So I think this one will be very, very fast as compared to what Peter or Michael said. So I think even though you get the correct output, but the execution time and then the resources.
Hello. Okay, you. Hello?
Yes. We
Okay.
can hear you.
So what I will do to resolve this, or you want me to resolve it my own?
Oh, we understand what you're saying. Like we understand each other.
Okay, that's fine. Our time is far spent, so I think we'll quickly rush through this with about, let me say, let's use just 5 minutes to go to the other slides, and I can share you the slides and also as well as this particular file. Go through, come up with your own solution with this and the other one that I gave you with a two-dimensional array, and we will have feedback on the page as well. Is that okay?
Yes, sir.
Okay, so let's quickly go to the other slides. The other slides also talks about iterators, and iterators just is a sample code. Instead of us to write, let's say, for loop and between all those condition and other things, there are some kind of keywords or some kind of inbuilt keywords that the programmers or the languages they have. When you use it, it does the iteration automatically for you, which we don't have to go and write the for loop and everything. On Ruby or Rails, you can just do, let's say, I have these names here: Bob, Joe, Steve, Janice, Susan, Helen. I can just say names.each, and I'll add a name over here, and I'll just say it should output all the names for me. So using the keyword put in Java, I'll say system.out.println. In here, for Ruby, I will just say put and output a name, and it will just be looping through everything and just be giving me everything over here. So that's what we have we call the iterators. And we also have similar also in Java. We also have the for each also loop, and we have it different for different languages. So when you're learning your own language, you can also learn the iterators over there. So just a touch on that, just to let you know that we have inbuilt functions that can automatically run this type of loops for us. So the last part here is called the recursions. Recursions is also not per se running the for loop and all, but then we can also use recursions to also run loops. So it's another way to create a loop in programming. Recursion is like you writing a program and the program calling itself over and over and over and over. So that one is also called a loop. In a way, it's not part of the for loop or the while loop or the do while loop. But then when you have a function and the function calling itself over and over and over, that one is also a loop. But then when you're using that one, you need to be very careful because your computer or your program can hang, because you can't have a function that can call itself like 1,000 years and it will be calling. It means the program is going to hang somewhere and it is not ideal solution. So if you are using that particular thing, you need to be very careful how you do it. You've all heard about the Fibonacci or the Fibonacci sequence or series when we're in commerce and also in elective mathematics. You also have all those over there. So basically, Fibonacci series is when you have one, let's say a number, and the following number will be the previous number plus your current number. So let's say if you have 1, the next number will be the 1 itself, because there's no value behind 1. Let's say if the value before 1 is 0. So you're going to have, let's say, another classic example is they're using calculating Fibonacci series. So it's Fibonacci series of numbers in which each number is the sum of the 2 preceding numbers. So let's say 1. And since there's no number preceding 1, we come to another 1 again. Now, when we combine 1 and 1, we get 2. Now, when we combine 1 and 2, we get 3. When we combine 2 and 3, we get 5. When we combine 3 and 5, we get 8. When we combine 5 and 8, we get 13. And it goes on and on and on and on. So there's an example of Fibonacci series. And if you want to print this type of Fibonacci series, you can have a function that can be calling itself and be giving you these particular outputs. So there's just a classic example of recursions in programming. So I'll just give you just 2 minutes if you have any question, and we can close. Our time is fast spent. I'll share the file and also the slides with you. If you have any questions, just buzz us on the page and we just answer you. Any question?
No, but I'll say thanks to you. Thank you, and then the team for
All right.
helping with the young ones. I mean, the young programmers.
All right, cool. You're welcome.
Yeah, but one thing is that I don't know why you're using different languages to teach. Even though you explain to us that this is done in Ruby, this is done in here. Mixing the syntax makes it sometimes I'm confused myself, because if we are teaching this side, we are using this, and then when we are teaching this thing, we are using this syntax. So I don't know why the team is doing that, but I think if you can revise that for us,
okay.
That's my humble plea.
Thank you for the submission. Thank you very much.
You're welcome.
Okay. But one thing also we should bear in mind that coming February, we are going to split into different classes, and that's where we are going to start actual practical programming.
Oh, that's great. That's great.
By end of this month, we are going to split all of us, and we are going to send you some forms for you to fill, so that you just let us know where you want to go. You know, in our first session, we let you understand that we have mobile development, we have backend development, we have the web and the website and other things also development. We are not going to touch on DevOps. DevOps is like another thing altogether. So I want to